Lorenzo. I hope your name right. Okay, from Lomonosov, Moscow State University, and he's going to talk about very similar to the first presentation, the impact of the cities on convective.
Good afternoon, dear colleagues. This presentation was planned to be done by other colleagues from our team, but unfortunately they didn't manage to come because Australia is a bit far away from Moscow. But I will try to do my best to introduce our joint results. So it will be a story about urban impact on atmospheric convection and associated precipitation. So few aspects of motivation for this topic, they are generally well known. Firstly, we have climate change. It impacts temperature, then it impacts moisture and statistical stability of the atmosphere, and this stuff is leading to amplify severe convective events. So we will focus on such events in our study, and as the first presenter already shown, such events may be amplified over urban area due to different physical mechanisms. There are plenty of nice reviews about this topic, and we are studying these problems for Moscow, which is the largest European megacity with population about more than 15 million people. And a few years ago, we already got this nice result that based on high-resolution simulations for 10 summer seasons, we found this increase of seasonal precipitation sum for warm season. It's about 10% for the city center, but it is mean result average over 10 years. And in this study, we will try to dive deeper to the story and analyze the impact of the city specifically on severe convective events. So we use the modeling results obtained with Cosmos LM model with 1 kilometer resolution. The model was used to downscale air interrimmer analysis with and without urban canopy parameterization. There is quite simple but effective urban canopy parameterization called TerraUrb. And we analyze, in this study, we analyze a large amount of statistics, different metrics of precipitation, hourly and daily precipitation sums, wind speed, vertical velocities at different levels, and two interesting parameters. First is updraft helicity, which is an index proposed to identify supercell-like structures, and compound events when we have extremes of wind speed and precipitation simultaneously. So such events are most dangerous for urban infrastructure and population. And so let's start with precipitation. There are results of urban impact of the repeatability of days with precipitation more than 20 millimeter and 30 millimeter. And we clearly see the urban impact over the city center and to the northeast from the city to leeward side for both these grades. But if we consider different precipitation grades, we see that impact is very weak for weak precipitation. Then it increases about 10 millimeter per day and about 40 millimeter per day. So this occurrence of model grid cells in wall domain with when this threshold is passed. So the city impact precipitation in the range from 10 to about 40 millimeter. And these are results analyzed over space. There are several samplings of the grid cells. These are these are results for urban experiment with urban scheme and grid cells inside the city. And this is the number of days with precipitation higher than 30 millimeters. And there is clear difference with the same distribution for no urban experiment. And these are heads for grid cells outside the city. Also, you can see that there is quite clear difference in statistical distribution. Then let's look on the wind speed. It is maximum wind speed resolved by the model, so without gust parameterization. And we again see quite clear urban impact on the repeatability of high wind speeds, higher than 20 millimeter per second and higher than 25 meter per second, of course. Again, these impacts are localized inside the city and also may go beyond the city borders. And again, as for precipitation, we see this urban impact, which is shown by this blue line, increases with increase of wind speed. And this is, now we look what are the physical mechanisms beyond these changes. And these are results for vertical velocity at the height of 2 kilometer and 5 kilometer. And in both cases, we have very significant increase of the vertical velocity over the city. So this is really surprising that the city impacts vertical velocity even at 5 kilometer height. This is again vertical velocity, but not mean values, but it's quantile values. And again, we see very clear urban impact on this parameter, even at 5 kilometer height. And previously we had 99 quantile, and this is 0.999 quantile. Again, urban impact exists. And this is this specific parameter proposed to identify convective supercells, updraft helicity. And as for vertical velocity, we have its increase over the city for different quantile values. And as for precipitation, we have the largest urban impact for intense, but not the most extreme values, so in this range. And another interesting parameter that we analyzed, so-called compounds events. And this plot shows repeatability of these events over 10 years of our numerical simulations. And here there is a methodological question how to define them, because these events are defined according to quantiles, and we can calculate these quantiles based on simulations with city or on the simulations without city. And these estimates will be different. So there are three options. Estimate for no URB simulation, where we have in total 74 cases, and two estimates for urban simulation. The first one is based on the thresholds defined from no URB simulation, and the second based on the thresholds defined for this URB simulation. And in both cases, we have a significant increase of such events over the city. So these are now time to go to conclusions. So we found urban impact on precipitation, including intense precipitation, vertical wind speed, and updraft helicity parameter, which is quite new in such studies. And we found statistically significant increase of vertical velocities over the city, which could be the driver of the other impacts. And another interesting conclusion that we found urban impact, the most intense urban impact on the intense but not the most extreme daily precipitation. And also we found a significant increase of the frequency of compound events with dangerous wind speeds and precipitation zones. So in general, urban canopy effect in the model lead to increased vertical transfer, which promotes convection and these events. And it's interesting that this model-based results qualitatively agrees with observations, and we have another poster presentation about the same topic, but based on long-term observations. It's also today in poster section, so you could come and compare. Thank you for your attention.
Thank you. Thank you. Very interesting talk, and we have time for a couple of questions.
I thought clouds formed near the top of down layer is the convective ones responsible for rain. So how much do you think this 5 kilometer updraft contributes to cloud formation, or is it above the layer where most of the clouds are forming?
Actually, we didn't compare yet a connection with clouds, so these are results calculated for the whole period. But from the physical understanding, we could imagine that this, of course, should affect clouds, because usually clouds have lower bottom.
You have a model results.
Yeah, yeah.
Hopefully you can look at
of course.
how they are impact low level clouds, middle level clouds, and high level clouds.
Yeah, thanks for this idea. We
Look at it. Right.
will take it into account.
Yeah, very good. You have a question on the back? Yeah.
Thank you for your great presentation. And I have a question. You found the more intense.
Can you speak louder so we can hear you when you come forward? Thank you.
Your results show that you have a stronger surface event in the urban case, right? As far as I see, the urban underlying surface will decrease when the surface wind speed. So why do you have stronger results?
This is of course this is because we use model, and actually the wind which is simulated by the model, it could be interpreted as the wind over the roofs, because we have urban, and this wind speed is really amplified because of